Wonder if this is working. Evening, ladies and gentlemen. Or good morning. Sorry, not evening. Good morning. I thought I'd start this video a little different today with my face. Give you a little taste of what the inside of my house looks like, I guess. So if you're wondering, yes, this is our Christmas tree. And so what me and my girlfriend do is instead of taking it down, we just kind of decorate it with stuff based upon that month. Now, a bunch of hearts on there, so you can see we haven't decorated it since Valentine's Day. That being said, it's not really anything we could come up for March. So, if you have any ideas for April, feel free to shoot me an email on what you think we could do in order to decorate our Christmas tree for the month of April. We've thought, maybe flowers, but that's more for May. So April's kind of a weird month. I mean, we could put some eggs up there, I guess. But anyway, if you got any other ideas of things I could decorate for our tree, shoot me an email. Make sure it's appropriate. That being said, let's get started on some math work. Okay, so let me sign in here. All right. Hope you guys are all doing okay. All right. These videos are probably not as great as being in the classroom, but shoot me an email if you have any suggestions as well on ways I can try to help you guys out. Okay, we're all working together in this, so let's make sure we're communicating on a regular basis if we have any sort of issues. Okay. That being said, it says complete work on a separate sheet of paper, blah, blah, blah. All right, we're talking about linear functions, okay? So that's what this section is going to be about. And so the first problem says which table of values represents a linear relationship, okay? And so what we are looking for here is when we're talking about linear functions, okay? One important thing to remember is, let me write what this looks like in what we call slope-intercept form, okay? Slope-intercept form. All right, there's two other forms, but this is the one we're used to at least putting at least the form we're used to putting these things in, because for one, it gives us both pieces of information on what our slope, what our intercept is. Okay, so that's our slope, that's our y-intercept, right? So hence the name slope-intercept form, but it's also, once we have it in this form, it's a lot easier to graph as well. But what we got to remember about the word slope, okay, and it only applies to linear functions, okay? The slope in linear functions is always constant, okay, which means it is increasing or decreasing by the same amount each time, okay? So the change, change in y values is constant. Okay, so over here to the left, what we're looking for here, right, as you can see, all of our x's are increasing at the same amount, right? 0, -1, or I'm sorry, -1, 0, 1, 2, 3, okay? Our x's are constant, okay? And we're looking for a constant rate of change, or a constant, increase or decrease in our y values here. That's what this thing represents here. This f of x is just a fancy way of saying y. Okay, and so let's go to the first one. So it increases by 1 here, and it looks like it increases by -2 to 1, so it looks like it increases by 3. 1 to 6 increases by 5, and 6 to 7 it's increasing by, or 6 to 13 it's increasing by 7, okay? So as you can see, this one is going up, but it's not going up by a constant amount here. Okay, it's not going up by the same thing each time. So that one's out. Let's take a look at this one right here. This one looks like it's increasing from or I'm sorry, from negative 1 to 0, it's going up by 0.5, right? From 0 to 1, it's going up by 1. From 1 to 2, it's gone up by 2. And 2 to 3, it's gone up by 4. So it looks like it's actually getting doubled each time, all right? And so we should be familiar with what kind of function that is, or at least some of you might remember, okay? Anytime you're multiplying by the same amount each time, it's called exponential. So that's an exponential function, so that is not linear. Let's take a look at this one, okay? From negative 3 to negative 1, we've increased by 2. From negative 1 to 1, we've increased by 2. From 1 to 3, we've increased by 2. And from 3 to 5, we're increasing by 2. Okay? And so it looks like this is probably our right choice. But let's take a look at the third one, just because you always, never know with these regions. But we're pretty confident. This one's going from negative 1 to 0, so that's 1. 0 to 1, that's 1. And then it makes a jump from 1 to 8, which is 7. So this one is definitely out as well. Okay, so our answer to number 1 is 3. Let's take a look at number 2. Which function has the same amount, or the same y-intercept as the graph below? Okay, so let's zoom in on this graph below here. And it's a little blurry. Okay, but here's our line. And we're looking for when it crosses this axis, which is right at that point right there. And so that point is 0, comma, negative 3. That is our y-intercept. Now remember, all right, we were just talking about this form in the last problem, y equals mx plus b. So our goal in this problem is to take all 4 of these and put them into that form. And once we have them into that form, all right, we'll be able to figure out which one of these has the same y-intercept here. And so we're looking for negative 3. So this b, we're looking for a b value of negative 3. Okay? So, let's take a look at those problems. Okay, so let's take a look at this first one here. All right, so we got 12 minus 6x over 4 is equal to y. All right, so what we want to do here is we actually want to take this 4 and divide it into both of these chunks. Okay? And by doing so, we get y is equal to 12 divided by 4, which is 3, minus, and then 6 over 4. We could simplify that fraction by dividing each piece by 2. So we'd get 3 over 2x. Okay? Now, it's not quite in this form up here yet, but all we would have to do is just switch that 3 and that negative 3 halves over x. So we would get a negative 3 halves x plus 3. Now, mind you, we look back at our y-intercept and it's negative 3. Okay, so this one was close, right? But 1 is out. Let's take a look at the next one. Okay, in order to get y by itself, we're first going to have to subtract 27 from both sides. Okay, so when you subtract 20, ooh, pen's running out of ink. Come on, don't do this to me. So when you subtract 27 from both sides, okay, so you get 6x minus 27. And then when you divide both sides by 3, make sure you divide both the 6x and the negative 27 by 3. Okay, you're left with y equals 6 divided by 3 is 2. 6x minus 9. So again, our y-intercept is negative 3, so 2 is out. Let me pull up a different color here, okay? All right, let's try number 3. Okay, so this one's going to be 6y plus x equals 18. All right, so in order to get y by itself, we have to subtract the x. So you subtract x from both sides, you get 6y is equal to negative x plus 18. Divide by 6, and you get y is equal to negative 16x plus 3. So again, this one is out because we're not looking for a plus 3. We're looking for a negative 3. So it has to be 4. But let's show why. Okay? So we're going to have y plus 3 is equal to 6x. All right? In order to get y by itself, all we'd have to do is just subtract 3 from both sides. We get 6x minus 3. So here we go. We have a y-intercept. Again, this is y equals mx plus b. In this case, our b is negative 3. So our answer is 4. Okay, so that is number 2. All right, moving along here. I'm going to switch colors up. I'm going to go to green. Okay, so the graph of a linear equation contains the points 3, 11 and negative 2, 1. Which point also lies on the graph? Okay. So a nice way to handle this, let me zoom in here for everybody. Okay, what we're going to have to do, it's going to involve the point slope formula. And our calculator. Okay? So involve both of those things. So, why do we need to start with the point slope formula? Well, here's why. Okay, so in order to find out whether or not one of these points lies on the graph or lies on the graph of our linear equation, we first must know what our linear equation is. Okay, which we don't, but we can find it with these 2 points right here. Okay, so let me rewrite these points out over here. It's 3, 11 and negative 2, 1. And what I'm going to do, this is going to be x1, y1. It's going to be x2, y2. So I'm going to start with the y2, so it's going to be 1 minus 11 all over negative 2 minus 3. I guess I didn't need a set of parentheses there because it's positive. All right. So, what happens when we solve that out here? We get 1 minus negative 11, which is negative 10, over negative 2 minus 3, which is negative 5. Negative 10 minus 5 is a positive 2. Okay, so let me rewrite these colors in here because I think they might be confusing. This is -2 minus 3. Okay, so it's y2 minus y1 or x2 minus x1. Okay, that is our point slope formula. I apologize for not showing you that first. Okay, that's what that is. So now, what we just found is this, is the slope of our equation. But we're still not done here yet. Okay, so now we got to take one of these points and we got to set up an equation. Okay, so I'm going to choose the 3 and the 11 because they're both positive. We're going to stick with some nice positive numbers here. All right, so I'm going to go y minus y1 is equal to the slope times x minus x1. Right? In this case, our x1, y1, we're going to use this 3, comma, 11. So I just plug that in. So y minus 11 is equal to our slope, which is 2, x minus 3. Move this over. Give ourselves some space. Now I'm going to distribute that 2. So I'm going to get y minus 11 is equal to 2x minus 6. Add 11 to both sides. You're left with y is equal to 2x, and negative 6 plus 11 is a positive 5. So, that is our equation. So let me move this. Oh, that didn't work. Crap. Start again here. And rewrite this over here. Just to give ourselves some space. It would be y equals 2x plus 5. All right? So that is our equation. Now, we're going to take this equation. We're going to plug it into our calculator. Okay? Let's take that equation, plug it in your calculator. Y equals 2x minus 5. And don't go to your graph, go to your table. And what we're looking for is we're looking for whether or not this point, okay, if one of these points, ooh, I put minus 5. Hello. I was like, didn't match up on mine, right? Because I put minus 5. It's 2x plus 5. Holy smokes. Okay, let's go to my table. And at 2, I'm seeing 9. Okay. So when you look at your table, when you have an input of 2, you should see your y value as a 9. Okay. That's one way of doing it. Also, another way you could have done it, okay, is to just plug all these values in. So 9 is equal to 2 times 2 plus 5. And does that check out? Sure does. 2 times 2 is 4, plus 5 is 9. Okay? That's another way you could check to be sure if you don't feel like using your calculator. But I encourage the use of your calculator there. It saves you some time. Okay? You got your formula here. And just plug it in your calculator and check your table of values. Okay. Number 4. Let me zoom in here. Okay. 2013, the United States Postal Service charged 46 cents to mail a letter weighing up to 1 ounce and 20 cents per ounce for each additional ounce. Which function would determine the cost in dollars, okay, C of Z, of mailing a letter weighing Z ounces where Z is an integer greater than 1? Okay, so let's think about this one for a second. Now, this one's a bit tricky. So let's kind of break this down anyway here in the pieces, okay? So it says well, let's think about this one here. Okay, so it says the United States Postal Service charged 46 cents to mail a letter weighing up to 1 ounce, okay? So that's key. Now, that's going to play into part later here, okay? And then it says, and 20 cents per ounce for each additional ounce. That's another key part here. Okay. Let me actually pull up a different color here. So this one does 20 cents per ounce for each additional ounce. Okay, remember we're talking about linear functions. So when we're talking about linear functions, we're looking for that constant rate of change. And this is what we would call our constant rate of change, okay? It's 20 cents per ounce. So for every additional ounce, okay, you're getting charged 20 cents per ounce. All right? Now, so they do put an answer down there that looks very similar to what it is you would suspect it to be, okay? So let's read this first part here that I've kind of put in the box. It says 46 to mail a letter weighing up to 1 ounce. All right? Now, that is important because if you look down below here, right? Also, this would be kind of considered our y-intercept, all right? Right? It's like our starting point. I apologize. Let me write that in there. This is like our starting point. Okay? So, you're initially paying up to you're paying 46 cents for any letter weighing up to 1 ounce. Okay? So if it weighed half an ounce, 9/10 of an ounce, okay, all the way up to an ounce, you're getting paid. You're gonna get charged 46 cents. Okay, now it's 20 cents per ounce for each additional ounce. Now below here, right? So let me also write this in there. So this is our slope, okay, and this is our starting point or our y-intercept. All right, and if you look down here, okay, we see one that looks very similar to what it is we would suspect, right? Our starting point is 46 cents, and you're getting charged 20 cents for each additional ounce. Okay, let's think about what this function would look like here, okay? So, let's say we chose this function here. We chose to mail a letter weighing up to 1 ounce. Erase this part here. Write this over here. Okay, so thinking about what the problem was stating in the beginning here. Okay, you're getting charged 46 cents to mail a letter weighing up to 1 ounce. So if I'm based off of this function I just chose, okay, so I'm getting 20 cents times 1 plus 46 cents, okay, which means it's 0.2 plus 0.46, which is 66 cents. But wait a second. What does our problem state up here? It says we are getting charged 46 cents for any letter weighing up to 1 ounce. All right, so I got a letter weighing 1 ounce. All of a sudden, I'm getting paid, or I'm getting charged. I'm getting charged 66 cents instead of 46. So the problem with this function number 2 here, okay, is that it doesn't take into account that we're not getting charged an additional 20 cents till actually 2 ounces. If you think about it, right? You get charged 46 cents up to 1 ounce, and you're not getting charged an additional 20 cents till actually our second, when we weigh 2 ounces. Okay, so at 2 ounces, so let's think about this. At 1 ounce, we're getting charged 46 cents. And at 2 ounces, we're getting charged 66 cents. All right, so one of these is the correct formula. All right, now we can cross this one off, right, because this one is completely wrong. Because 46 cents isn't our slope, that's our starting point. So we can also cross off number 3. Okay, so cross off those 3. So let's show why it has to be number 4. And so maybe let me erase some of that stuff so you can actually see. All right. Let's take a look at this one. All right, so if we plug a 1 into this one, we get 0.2 times, now anywhere you see a z, you're going to put a 1 plus 0.46. Now 1 minus 1 is 0, and anything times 0 is just 0, so C, so at 1 ounce, we're getting charged 46 cents. All right, so that one checks out. Let's look at 2 ounces. So 2 ounces, so anywhere I see a Z, I'm going to put a 2. And so here, 2 minus 1 is 1, and 1 times 0.2 is 0.2 plus 0.46, which is equal to 66 cents. And so that one checks out as well. Okay? So that is why number 4 is the correct answer and not number 2. Okay, you would suspect it to be number 2 because 46 cents is our starting point. All right, but you got to remember that we're actually not getting charged an additional 20 cents until 2 ounces. Right? So realistically, it's kind of an imposter starting point. It's not. It's not technically our starting point. If we were to, so let me just simplify this right here. If we were to, 0.2. I'm just going to move that back. 2 times z minus 1 plus 0.46. Right, we would get 0.2. This is going to look messy. Z minus 0.2 plus 0.46. So our starting point, I'll put this in a different color, is actually 0.2 Z plus 0.26. Right, so that's actually what our formula in a simplified form would look like. All right, so anyway, that one's a bit tricky, so that's number 4. Hopefully that helped you guys out there. Okay. So, the amount Mike gets paid weekly can be represented by the expression 2.5A plus 290, where A is the number of cell phone accessories he sells that week. What is the constant term in this expression, and what does that represent? Okay, so we're talking about the constant term here. All right, and so, again, we're referring to that special word that we only see when referring to linear functions. And it starts with an S. Then it goes to an L, O, P, E. What's that spell? Spells slope. All right? So we're talking about the slope. What is the constant term here? What is it increasing by each time? Okay, so let's take a look at what this function looks like here. So 0.25a, well, I'll put the 0 there, I guess. Okay, plus 290. All right, and we'll just say this is a function of a. Okay, so we have our, actually they want to leave it as an expression, so we're just going to take that out. Okay, but anyway, regardless, Okay, what is our constant term here? All right, so if we were to look at our form, y equals mx plus b, okay, our m is always that number that, or our slope is always that number that appears before our variable, our input, okay? So in this case, our input is a, and what comes before the a? 2.5, or 250, all right? So our constant term here, or our slope, is not 3 or 4, okay? It's one of these two. And now we have to decide which one of these is not the correct representation, okay? So we've currently just decided, all right, our slope, or our constant term, okay, is 250. And now what does that mean? So let's reread the problem. The amount Mike gets paid weekly can be represented by the expression 250, or 2.5 times A plus 290, where A is the number of cell phone accessories he sells that week. Okay, so let's think about what the A represents here. And so the A, in this case, represents the amount of cell phone accessories he sells that week. So in this case, that is number 2. Okay, so 2.5 times A, comma, the amount he earns when he sells accessories. Okay, so for each accessory he sells, he earns an extra $2.50. Okay, and that is our answer to number 5. Alrighty, stay on top of the homework, you guys. Stay posted. Stay in touch. All right, any questions, feel free to email me, myself, Miss Hellier, or Miss Costello. You know, feel free to stay in contact, you guys. Okay, so supporting you guys. We're all working together through this, and like I said, any sort of suggestions or sort of feedback we get from you guys will help us better generate much more fulfilled lessons. So anyway, hope you guys enjoyed my video here. Hopefully enjoyed the little beginning there. I'll try to do something new each week in order to get the week started, because I know it can be kind of a drag watching these things. So I appreciate those of you that